Okay, let's take a look at these 4 questions from the textbook. They're actually a little harder than they look. I'll fill in what we know in red. So if I read the question, it says R1 is 30 ohms. That's a 30 ohm. R2 is 50 ohms. Okay. R3 and R4 are 60 each. 60 ohms, 60 ohms. And the power supply is 12 volts. Hold on, no, V1 is 12. So this guy here is 12 volts. Okay, that's everything we know then. So those two are series, this is in parallel. You can group this together to get the total voltage on that side. Let's take a look. We got two numbers right here, so we always know VIR. So we got two numbers right here. We can go I equals voltage, 12 over R. I guess we should start doing pencil because this is calculations now. 12 divided by 30 gives me a current of 0.4 amps. So that's what's coming through here. 0.4 amps is passing by this guy. The exact same 0.4 go by there. Same 0.4 amps comes by there and then out of this side. There are electricity going that way, but let's do this side here. Now I have two numbers here again. So we know that V equals IR. So I can get voltage for this one. And the current is 0.4 and the voltage is 50. The resistance is 50, so that gives me 20 volts. Okay, so we got 12 volts here, 20 volts on this one, which means every electron taking this way has to drop 32 volts of energy. So if I was to circle this whole package, that would be 32 volts going through there in total, which means that this side also has to be 32 volts because any electron going the top trail, going back to the battery with nothing, is the same as the guys in the bottom going back here with nothing. So we know the battery is 32 volts. Let's see what this question's asking for. I was going to do everything, but they want to know the total current. Okay, so we have the voltage, 32. Let's get the total current here. I have 0.4 amps going this way. I need to know how many are going that way. This whole package would be 120 ohms because I have to go through 60 through 60. So now I have voltage and resistance. I can get I. I on this other trail will be voltage over R, which is 32 over 120. 32 divided by 120 comes out to 0.26 repeating amps. So we got 0.4 going that way, 0.26 going that way. If we add them together, the total would be 0.66 amps. I think that's what they're looking for. So the total current, oh yeah, so they just want the 32 volts and the 0.66 amps. Repeat. Okay, question 63. Let's write down what we know. R1 and R2 are the same. R3 is 150. And this one is 200. Up this way, 4 amps are going down this trail. The source is 15 volts. Okay, that pretty much locks everything in. And these guys are equal to each other. R1 and R2 are equal, so the voltage would just split across there. So 4 amps are going by here. Let's switch to pencil because then we know this guy is also 4 amps because it's the same 4 amps going through there. The total voltage is 15. So if this comes along here, these guys are equal. Those two resistors are the same. So the voltage will split up perfectly. So there'll be 7.5 here and 7.5 volts in that. So the electron that says, hey, we're going this way, like 4 of them do, and they lose their 7.5, lose 7.5, come back here with nothing, go to the battery and get charged. Okay, going down this way, we're going to have some current. What do we want to know? Find R1 and R2. Okay, so let's take a look here. We have voltage and current, so I can find R. V over I, which equals 7.5 over 4. 7.5 divided by 4 is 1.875 amps, going by that trail. Or that's the ohm, sorry. 1.875 ohms. And there's two of them. You can multiply by 2 to get the whole row, but they just wanted to know the one. I think the back of the book says 55, but that can't work out at all. Because if you take a look at this side, they want to know how much current's going down this way. I need to find this current here. This is series, so this will give me a total resistance of 350 ohms for what I circled. And we know the voltage on that whole thing would be the 15 volts. So I can find I. I equals V over R, which will be 15 over 300. 15 divided by 300 is, oh, it's not 300, it's 350. 15 divided by 350 is 0.0428, so much as 3 amps. I'm not even sure. I think the back of the book had something much smaller than that. So I'm not sure what they did. Maybe they got the voltage mixed up at the beginning. But that's R1, R2, that's the current. Okay, 64. The source is 50 volts, okay. And the current's 0.25. Okay, they threw that at us. R1 is 100. And what else do we know about this? V1 equals V4. Oh, so this voltage will equal that voltage. These guys are locked together, okay. Whoever made up these questions, they just loved algebra. Just want to make it more difficult. R2 is twice R3. R2, okay, so if I did this, times 2, that'll give me that resistor. I think that's everything they give me, so. Oh, here's one here. Okay, so that means the current's going to split up unequally along these trails. So if we drew little arrows on here, you could say that 3 parts of the current went up and 2 parts went down. Because if I4 is a 2, 3 times 2 is 6, if that's a 3, 2 times 3 is 6, 6 equals 6, that would work out perfectly. So the current's going to split up in an unequal path. Hopefully the current's a nice multiple of 5, which thankfully it is. So if I say the current is, and I divide that by 5 because there's 5 parts going on here. Oh, I don't really need the calculator, but it's 0.05. Is each part. So if I multiply that by 2, that means 0. Oh, this was a calculator value. We'll do it in pencil. 0.1 amp goes that way, and this is 3 times 0.05, so that's 0.15. And this will be also 0.15 amps. So that's how much current's going through each one of them. And whatever that voltage is, that voltage is. So if I follow my electron through here, I have 50 volts. I will lose some here and lose the same amount there and end up with 0. So 25 divided by 2, sorry, 50 divided by 2 will be 25 volts here. And this one will also be 25 volts because the book said they're the same. Yeah, so we have a lot of 2 numbers here. We can get the total resistance. What are the values of R4? So now I can get that, R4, because R equals V over I is 25 volts over 0.1 equals 250 ohms. So this one is 250 ohms. I think they're looking for that one. I2 and I3. I2 we got is 0.15. I3 is 0.15. I2. I4 is going to be 0.1 amps. Okay, we got that. V2 and V3. They want to know these two voltages here. Okay, so this whole group here, it's a 25 volt drop. And this one is twice as big as that one, so we're going to lose twice as much voltage there. It's going to be split up into groups of 3. It's a 2-to-1 ratio, which 3 parts. So 250 divided by 3. That doesn't work out so nice. 25 divided by 3 is 8.3 ohms. Oh, what am I saying? Voltages. 8.3 volts for the one part. So that would be this guy here. And this one would be twice as much, which would be 8.333. 16.6. Repeat volts. So V2 and V3. So V2 is 16.6 volts and V3 will be 8.3 volts, which will add up to 25, which will complete the circuit. 25 plus 25 is 50. This 25 plus that 25 is 50, so the circuit is complete. Last one, this one is like one, hardly any numbers at all. What do we know? We know that the source is 34 volts. Okay. And the current is 0.11 or milliamps, but that's 0.11 amps. So you could get R total because I have the two numbers. Okay, so R total would be V over I, because 34 over 0.11. I think I'll probably just leave it like that because I'm pretty sure this is going to be a big fraction question. Let's fill in what we know here. R1 equals R4. Okay, so these two guys are the same. And now R2 equals 2 times R3. And 2 times R1 equals 5 times R3. And the initial numbers here. Okay, these two are equal to each other. So we're going to say R1 equals R4. And I'm just going to call that R from now on. That's our one variable. Okay, so this guy says R3. Yeah, so let's write down that as a... Now let's go to the pencil work. R3 equals 2/5 R1. Okay. R2 R3 we got here is half of that number. Okay, let's do that then. R3 equals 1/2 R2, and then I can stick that in here. That's R1. We're just going to call that R. Okay, because R1 is just R. We're just going to call that R from now on. So we got this guy. R3 is 2/3 R. So that's fine. We can use that. Now we just got to get R2 in terms of this guy. Stick him in over here. So this is usable. That's usable. Now I got to convert that in terms of R. I want everything just at R, and then we're going to set up the big equation. So R2. So sub it in here. 1/2 R2 equals 2/5 R. Multiply both sides by 2. R2 equals 4/5 R. Okay, these are all my variables here. Now we're going to set up in a formula to say, what's the total resistance of the circuit? Well, we'll use the scrap paper below. R total will equal that R, R1 plus, now we're going to do the series part, 1 over R2 plus R3 plus 1 over R4, and then I have to inverse that whole package. So We have a number for our total. We have all of the R values in terms of just R's, so we could figure this out. This would be R plus, and we got R2 plus R3. So that's 4/5 R plus 2/5 R, which is probably going to be 6/5 R. 1 over 6/5 R plus R4 is just an R, so that's just 1 over R, all inverted. Okay, let's try and find some common denominator. I gotta multiply both sides by 6/5 R, so that's gonna equal R plus, bracket, 1 over 6/5 R plus 6/5 on the top now, and 6/5 R on the bottom to get a common denominator. Now we can add them together. 6/5 plus 5/5 would be 11/5. So we're gonna have 11 over 5, 6/5 R, inverse. Oh yeah, plus R. Okay, let's see what we can cancel out of here. R e plus, divide that out, that comes out to 6/11, because base both's over 5, so R. That's what our total equals. That did collapse and shrink down much more than I thought. So this is going to be our total, which we know will be 34 over 11, 0.11, which will equal, let's add these together. That's 11 over 11. We can make it like this if you want. Common denominator is going to be 17 over 11 times R. And when you do the math on that, let's see. So we got 34 divided by 0.11 times 11 divided by 17. That's crazy. They actually did put some thought in that. It's R equals 200. So if you want to go back and figure all these out, you'd have to plug this back in here. So R1 is 200, R4 is 200. This R3 would be 2/5 of 200, and R2 would be 4/5 of 200. And all the numbers would work out nice. But not a very nice algebra question. Obviously a math guy made that one up.